Welcome to our lecture online. Now let's see what the reduced mass effect is on the calculation for the wavelengths of the photons emitted when we have an energy jump, let's say an electron jumping from the third level down to the second level in hydrogen. So we're looking for the alpha, the H alpha line, that red line that's produced in that transition. So if we first start the calculation using the theoretical value for the Rydberg constant, we have a value for the wavelength of 656.114 nanometers. But what happens when we now use the Rydberg constant, which is calculated using the reduced mass? Well, that changes the Rydberg constant from this to this value. It's a small change, but it's big enough to notice that, yes, instead of 656.114 nanometers, we get a value of 656.473 nanometers. Now, experimentally, the value that we get is closer to 656.3 nanometers, somewhere in between the two values. But at least you see that the correction by using the reduced mass instead of the theoretical mass or the actual mass of the electron gives us an actual better value for the wavelength. Of course, there needs to be a couple more adjustments. There's some other adjustments for the speed of the electron, the relativistic values, and for the fine splitting and so forth, and for some of the interactions. But again, notice that all these will simply give you a little bit better value for the wavelengths calculated. And using the reduced mass is definitely a correction over using the actual mass and the theoretical value of the Rydberg constant. And that's why we do it. That's how it's done.